Hi everyone. In this lesson we want to talk about factoring trinomials when the leading coefficient is not 1. So if I have a trinomial like this, I know that it's going to factor as two binomials. And so I'm going to have 3x times x. That's the only way I can get 3x squared. And it doesn't matter which order I put these in. But then I have to find the factors of 12 that I can put in these two positions that will combine in just way with the 3x and the x in order to get negative 16x in the middle. And it's ultimately just a matter of trial and error, but there's some intuition that we can obtain to guide us. If I think about the factors of 12, I would have 1 and 12 and 2 and 6 and 3 and 4. Okay? Notice they come in pairs. And usually, unless this number in the middle is quite large, you don't want to start with what I call the outer factors 1 and 12. Think if I were to put a 12 right here, that'd make 36. That gets to be pretty big. About 80% of the time would be my estimate. It ends up being what I call the middle factors. And so if it's just trial and error and you're just starting out with a guess, unless this number in the middle here is fairly large, then I would just start with those middle factors, 3 and 4. Now notice I wouldn't want to put a 3 right here, because that would mean I'd be able to factor a 3 out of this. And notice there's no way you can factor 3 out of this up here. All right? So I know 3 is not going to go there. I could try 4, and I could try 3 here. That would give me a 9x for the outers and a 4x for the inners. And 9 and 4, there's no way I'm going to combine that to get negative 16. So it doesn't look like 3 and 4 are going to work. So I just move on to the next factors, try 2 and 6. Now again, I'm not going to want to put 6 right here, because then there'd be a common factor of 3. And there's no common factor of 3 out here. So let's try putting the 6 over here and the 2 here. And when I do that, if I do the outers, I get 18x and the inners are 2x. And there should be a little bell goes off in my head that says ding, ding, ding. 18x and 2x. If I combine those just right, I'll get the negative 16x in the middle. Notice I've not put any signs in here yet, but I do know that since this is negative, I know that the 2 and the 6 are going to have different signs, right? One's going to have to be positive and one's going to have to be negative to get the negative 12. And so if I subtract the 18x and the 2x in just the right way, I'll get negative 16x. So let's put the negative on the 18x factor, and let's put a positive on the 2x factor, and that'll give me my 3x squared minus 18x, and 2x makes negative 16x, and the last one gives you your minus 12. Okay? One other thing to notice that can help you if you're not entirely sure is if you were to graph y equals 3x squared minus 16x minus 12, there is a relationship between the factors and the zeros, right? If I were to set this equal to 0 up here, then I'd have an equation, and the zeros would be 6 and negative 2/3. And those zeros, in terms of the graph, are where the y value is 0. Okay? So if y is 0, notice that you can read right off the graph. Here is x equals 6. And this one's going to be the x equals negative 2/3 that corresponds to that factor. So if I were to graph it, I could see it looks like it crosses there at x equals 6. And then if I bring the 6 over on this side, that ends up being a factor, and that is the factor up there. And if you have one factor, that makes factoring it much easier. All right? So let's move on to this next example. Now in this example, you notice that it's written sort of backwards. We typically like to have our leading term, the squared term, in the left. It doesn't really have to be that way, but many students would want to go ahead and factor a negative out of this and then turn it around, so I'd get a negative 12a squared, and then I'd have to factor a negative out of the 35a, and a negative out of the plus 3 would leave you negative 3. Okay? So this would give me a negative, And in this case, again, I look at these numbers and I see a 35 right here. Notice that's pretty big compared to the 12 and 3. If I were to break the 12 here into smaller, you know, the 3 and the 4, or 2 times 6, combining those with 3 and adding is may not get me up as high as the 35 I need. So this is the one case where I'd start off with 12a and a, the outer factors that I had over here. And notice if I were to put a 3 here to combine with the 12 and a 1 here to combine with the a, 36a and 1a, if I subtract those just right, I will get negative 5. Well, how do I know I'll subtract them? Well, because this is a negative and I know these have to differ in signs. So if I were to put if I want a negative 35, I put a negative on the large factor, the 36, that'll make negative 36a, and then put a plus on the 1a. That does give me negative 35a in the middle. And then I've got the negative 3 here, and I do have a positive 12a squared. Okay, so I factored that, and notice once again that this would correspond to that 0 there of x equals 3, okay, or a equals 3 in this case, if you're thinking of this as an a-axis instead of an x-axis. Okay, and then this one here, you can probably guess that that one would be negative 112. All right, so let's go on to another one here. This one, if the leading coefficient is not 1, the first step of every factorization is always make sure there's not any common factors. And notice here there is an x squared I can bring out, and also there's a these are all even, so we can at least take a 2 out, maybe a 4. 4 goes into 16, but 4 goes into 68. But I don't think 4 goes into 70. So let's just go ahead and take out a 2x squared. That'd leave me 35x squared minus 34x plus 8. All right, and I don't see any other common factors in there. So let's think of factoring this as the two binomials. Again, unless this number in the middle is quite large, I would think of 35x squared as 5x and 7x. And again, it doesn't matter which order I put those in, as opposed to 35x and 1x, because I'm going to have to multiply those by 8. And if I do that, if I had one of those was 35, I'm probably going to get too big to get negative 34 in the middle. All right. Notice if this one's plus and this one's minus, I automatically know those are both going to be minus, right? Because I need a negative number times a negative number to get a positive number here. And then I would need the two negatives to make it negative in the middle there. All right. So if I were to, if I try 8, you know, 8's going to be too big with each of those. So let's go with 4 and 2. If I were to put a 4 here and a 2 here, that'd give me negative 20 and negative 34. Or negative 20 and negative 14 makes negative 34. Okay, so notice also, if I can sort of check this down here, this is the graph. This right here is the graph of y equals 35x squared minus 34x plus 8. And you'd have to zoom in on the calculator. Notice that this is the scales real close to the y-axis here, and this is 0.4. 0.4 is the 2/5 that we would get from this factor up here if I was looking for the associated 0. And this one right here, I'll bet you can guess that that would be x equals 4/7. It goes with this one. All right. If I were to graph the whole thing, it would have to come down and cross over here at 0 as well, because there's a 0 right there. All right, let's go to the last one here. I've got 20p squared minus 23pq plus 6q squared. The significance of this is there's another variable in here, but you should recognize that factoring this is basically the same as factoring 20x squared minus 23x plus 6. All right, so I don't really have to worry about the q. I just know that I'm going to have so many p's here, and then I'll have so many q's right here as opposed to just a number. So once again, unless this number is quite large, I would tend to start off with the inner factors like 4p and 5p as opposed to 20p and 1p, or even 10p and 2p. But if it doesn't work out, we'll try that. And then let's try the 6 here. Again, I would start with the middle factors unless this number here is quite large. Let's try 2 and 3. And if I were to put say a 2 here, I think, oh, wait a minute, that would mean that there's a common factor of 2, but there's not a common factor of 2 up here. So I don't want to put a 2 there. Let's try putting a 2 here and a 3 here. And if I do that, I'll get 8 PQ, and then the middle is 15 PQ, and 8 and 15 does give me 23. And I check my signs here. If this is plus and this one's minus, these would both have to be negative, and I would get let's double check it, 20p squared, and then I've got a negative 8 PQ minus 15 PQ is minus 23 PQ, and then there's the 6Q squared. So I think we factored that. All right, and this right here, this is the graph of y equals 20x squared minus 23x plus 6. If you graph that, you can find a 0. That 0 is x equals 3/4. And if you were to work backward with x equals 3/4, you'd have to multiply both sides by 4 and then bring the 3 over. And you'll notice that 4x minus 3, or in this case 4p minus 3q, that is one of the factors. And so again, if you're not entirely sure how to factor something that seems really complicated, you can always find the 0, work backwards to get one of the factors. Once you have one of the factors, it's pretty easy to fill in the other factor. All right, so thanks for joining me on this discussion of factoring trinomials where the leading coefficient is not 1.